Just before 6 p.m., students enter the classroom to find Mr. Fees dead of an apparent homicide. Everyone said they saw it coming. At 6, the temperature of the body is 80 degrees, while at 7 p.m. it was 75 degrees. It took a while for the campus police to get through the party. If the room is kept at a constant temperature of 70 degrees Fahrenheit, what is the time of death? I will be using Newton's law of cooling, which is T equals T ambient plus T object minus T ambient e to the negative kt. First, I will begin by substituting T with 80, which represents the temperature of the body when Mr. Fees was found. T ambient is going to be replaced with 70 degrees, which is the constant temperature of the room, plus T object, which is 98.6, which is the normal body temperature, minus T ambient again. I will start by subtracting what's inside the parentheses, which gives me 28.6. I will then subtract 70 from both sides, which leaves me with 10 equals 28.6 e to the negative kt. I will divide 28.6 from both sides. That cancels out, which leaves me with e negative kt equals 10 over 28.6. And I will use this equation for a later purpose. I will then get the temperature of the body after an hour has passed, which is 75 degrees, and I will put that into Newton's law of cooling equation. I will then subtract inside the parentheses, which gives me 28.6. I will subtract 70 from both sides, which leaves me with 5 equals 28.6 e to the negative kt. I will then replace e to the negative kt with 10 over 28.6. That cancels out, which leaves me with 5 equals 10 e to the negative kt. I am now going to replace the t with 1, which represents the hour that had passed, and I am going to replace e with ln, and I am going to divide 10 from both sides. I will then put ln 5 over 10 into my calculator, which gives me negative 0.6931. Equals negative 1 over k. I will divide both sides by negative 1, which gives me k equals 0.6931. I am now going to use e negative kt equals 10 over 28.6 to solve for t. Since I know k, I am going to put it in. Now I am going to replace e with ln. And I am going to put ln 10 over 28.6 into my calculator, and it gives me negative 1.05. And I will divide that by negative 0.6931. Negative 0.6931, and it gives me 1.51. But I am going to round to the nearest tenth place, which gives me t equals 1.5. So the approximate time elapsed from time of death to time of discovery is 1 hour and 30 minutes, which tells us Mr. Feast died at approximately 4:30 p.m.